Hi everyone, I'm Ag Stevens. I'm not going to talk through all those acronyms. So I'm from the Centre for Environmental Data Analysis, and got a poster here with Dan Clewley and Dave Moffat from Plymouth Marine Laboratory, who many of you will already know and have met yesterday. So we run the Jasmine platform and NERC between us. So Jasmine stands for Jasmine, NERC is the NERC Earth Observation, Data Analysis and Artificial Intelligence Service. Thank you. And so we run these two platforms that are quite highly aligned. We've got GPUs, if anyone's interested, and we're supporting the environmental science communities, primarily in the UK. So we're here just to tell you a bit more about what we've got available, the notebook services back with GPU, training and support, and access to lots of data. That's me done.
I'm Zishu Liu, a PhD student of University of Exeter, and my answer is about the remote sensing application, and I use the programming system and the vision transformer. The problem we find for fine-tuning the VIT on remote sensing datasets, this can be a very time-consuming. And another problem is the VIT, they only focus on the global relationship in the images, while the local features are abandoned during the classification job. And so we want to use a quicker structure, the bordering system. However, the bordering system have at least 3 parameters you need to adjust, and that's very difficult to find a suitable combination for the vanilla version. And then we have a combination version where we use the VIT encoder as a filter extractor and the bordering system as a classifier. And since the VIT will calculate the information for all the tokens, so the number of tokens are known, and we will use all the original tokens here, local patch tokens, into the input the feature mapping layer, and the CLS token, the global token, will use for the enhancement layer. And so we use all the tokens in the VIT. We do not waste any time and space. And by the way, and we can determine the number of windows in the bordering system, and with the help of the bordering system, the model trains faster than many deep learning models like we show here. I should remind you, all the time consumption listed here are running on CPU, and our model will only need about 100 seconds, while many deep learning models will require a few thousand seconds. And we can also improve our accuracy than the bordering system. Okay, thank you.
Hi all, I'm Matt Causon. I'm a first year PhD student at the University of Nottingham, and my research focuses on how we can move towards a more automated method for mapping lianas in tropical forests. So there's an image there of a liana. They're quite a complex growth form, and they use the structure of trees to support their weight as they sort of climb to the forest canopy in search of light. There's a couple of key things that motivate this work. Is that lianas have a net negative effect on the amount of carbon that's captured and stored within tropical forests, and they've also been found to be increasing in abundance across the tropics over recent years. So we're looking for cost-effective and time-efficient ways of mapping lianas, and you can detect lianas from above using UAV imagery, high-resolution UAV imagery. But we're looking to do that with computer vision models. So we're trying to calculate this metric, percentage liana cover, which is how much of an area of a tree crown is occupied by lianas. So my early work has worked on trying to get a good initial tree crown segmentation model working, and my sort of future work will look at being able to detect lianas and then automating that calculation. Yeah, thank you very much.
Hello everybody, so I'm filling in for Mahdis, Tourian, who is currently unwell. So this is a work that we have been doing in collaboration with Natural England. So the idea, as it was presented yesterday, is that field surveys are used to build the natural inland habitat map. And what we want to do with this project is try to use machine learning to classify images that are taken during the field surveys to validate actually this map. And so the idea would be in the future so that we can use crowdsourcing and machine learning to try to classify more images using this classifier, and so try to validate more thoroughly this natural inland habitat map with a machine learning method. So please come and see us if you are interested to this.
Hi everyone, my name is Oscar, and I'm an early career researcher here at the University of Exeter, working with Hywel, but also with Dan and Emmanuel from PML. So my poster is about how we can use LLMs, large language models, to improve the accessibility to observation data. So you can realize that we are having more and more platforms now that aim to gather at one place Earth observation data and products, so that the research about Earth observation data can be easier and faster. But if you take a close look at those platforms, we realize that they require expertise in data science or in QGIS or whatever. And those expertise make it difficult for people without any data science background to access those data. It's difficult for them to manipulate the data, especially people like farmers or decision makers who are willing to have information from observation data, but they don't have the programming knowledge to access those data. At the same time, we realize that LLM have shown the capability now to understand natural language queries, and it's also possible now to connect your LLM to any external API so that you can draw information from those platforms. And finally, LLMs are now good at presenting a report. So what we are trying to do in this project is to combine an agentic framework together with some existing LLMs so that people can use an interactive, friendly AI chatbot to extract data from any Earth observation data set. And this time we are focusing on the living way datacube, which aims to monitor the evolution, the change of a landscape in waves. So that at the end, people can use language query, conversational language to extract and access data, Earth observation data through LLMs. So I will be happy to talk to you more about this during the poster session. And thank you.